Okay students, now in the previous class we have learnt how to solve the equations which are not actually linear, but we can convert them in the form of linear equations by some substitution. Now let's discuss the conditions of solvability and the questions based on this. Conditions of solvability of linear equations in two variables. This is a very important topic because from this particular topic you may have the question, 1 mark question, 2 marks question, 3 marks question as well as 4 marks question. So let's see what are the conditions of solvability. So if the pairs of equations are a1x plus b1y equal to c1 and a2x plus b2y equal to c2. These are two pairs of linear, this is one pair of linear equations in two variables. Now as we have discussed in the very first lecture that whenever we represent any linear equation on the graph, it always represents a straight line. So as we have two equations, definitely it will represent two straight lines. So when we draw two straight lines on the graph, we have only three possibilities. Number one, the lines are intersecting each other. Number two, the lines are coincident lines. Number three, the lines are parallel. So, if the lines are intersecting, that means the pair of equations will have exactly one solution, and the condition for solvability is a1 upon a2 is not equal to b1 upon b2, and the system is said to be consistent. Secondly, if the lines are coincident, overlapping each other, that means it has, the pair of equations have infinitely many solutions, and the condition is a1 upon a2 equal to b1 upon b2 equal to c1 upon c2, and definitely the system of equations are said to be consistent. Then the third case, parallel lines. It represents no solution, and the condition is a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2, and in this case the system of equations are said to be inconsistent. So now let's discuss what do you mean by the term consistent. Consistent means the pair of equations are said to be consistent if they have at least one solution. If the pair of equations have at least one solution, the system is said to be consistent. And if the pair of equations have no solution, then the system of equations is said to be inconsistent. Now, in this case, we can say the system of equations are consistent and they have dependent solution. The solution is said to be dependent. In this case, the system of equations have exactly one solution, only one solution. So from here, you may have a 1 mark question that how many solutions can a pair of equations have? The options are 1, 2, 3, infinite. The answer to this question will be it may have 1 or 2 or infinite, 1 or 0 or infinite number of solutions. The pair of equations can have either only one solution or no solution or infinitely many solutions. Now let's discuss some questions based on this, that how to check whether the given pair of equations have how many solutions or whether the equations are consistent or inconsistent. So the first question you may have here, that is, identify the type of lines represented by the following pairs of equations. Identify the type of lines, that means you have to show whether the lines are intersecting or parallel or coincident. Let's take some examples. If the equations are 2x plus 3y equal to 5, 3x plus 2y equal to 7. Now in this pair of equations, a1 upon a2, a1 upon a2 is equal to 2 upon 3, b1 upon b2 is equal to 3 upon 2. So from here we observe that a1 upon a2 is not equal to b1 upon b2. So according to the question, the answer is they will represent intersecting lines. Let's take another example. If the equations are 3x minus 4y is equal to 9, 6x minus 8y is equal to 11. Again, a1 upon a2 is equal to 3 upon 6, which is equal to 1 upon 2. b1 upon b2 equal to minus 4 upon minus 8. It is again equal to 1 by 2. And c1 upon c2 is 9 upon 11. Hence, we observe that a1 upon a2 equal to b1 upon b2, but not equal to c1 upon c2. Therefore, the pair of equations will represent parallel lines like a railway track. Third example. Example number 3. If the equations are 5x plus 2y equal to 14, ten x plus 4y equal to 28. So in these equations we have a1 upon a2 equal to 5 upon 10, which is equal to 1 upon 2. b1 upon b2 is equal to 2 upon 4. Again it is equal to 1 upon 2. c1 upon c2 is 14 upon 28, which is again equal to 1 by 2. So here we get a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. Hence, the pair of equations will represent coincident lines. Okay? Now, second question. Now the question is, how many solutions can the given pair of equations have? If the equations are 3x plus 2y equal to 7, 3x plus y equal to 9. Let's find out the ratio a1 upon a2. We get a1 upon a2 3 upon 3, which is equal to 1. b1 upon b2 2 upon 1, which is equal to 2. So from here we observe that a1 upon a2 is not equal to b1 upon b2. So the pair of equations will have only one solution. Second, if the equations are 2x minus y is equal to 5 and 4x minus 2y equal to 7. Again we find out the ratio a1 upon a2, 2 upon 4, that is 1 upon 2, b1 upon b2 minus 1 upon minus 2, which is equal to 1 upon 2. C1 upon C2 is 5 upon 7. So what we observe, A1 upon A2 equal to B1 upon B2. So we observe that A1 upon A2 equal to B1 upon B2 not equal to C1 upon C2. And this condition represents parallel lines, means the pair of equations will have no solution. Third example you can take, 2x plus y equal to 8. X plus y by 2 equal to 4. Let's find out a1 upon a2, 2 upon 1, which is equal to 2. b1 upon b2 is 1 upon 1 upon 2, which is again equal to 2. C1 upon C2 is 8 upon 4, which is again equal to 2. So we observe that A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. Hence, the pair of equations have infinitely many solutions. Similarly, just by finding the ratios, we can also identify whether the system of equations are consistent or inconsistent. As we have discussed earlier, that is, consistent means the pair of equations should have at least one solution. So if we consider the same examples, in this case it is consistent, B it will be inconsistent. This is consistent. This one is inconsistent. And the last one is also consistent. So this way you can have 1 mark question from this particular topic that identify the type of lines represented by the given pair of equations without drawing the graph, or how many solutions does the pair of equations have, or identify whether the system of equations are consistent or inconsistent. Let's discuss some other variety of questions based on this. For example, find the value of P. Find the value of P. Question number 3. Find the value of P for which the pair of equations have exactly one solution. Have exactly one solution. 9x plus py minus 1 is equal to 0, and 3x plus 4y minus 2 equal to 0. Let's discuss the solution. The condition which is specified in this question is exactly one solution. First, let's write the values of a1, a2, b1, b2 and c1, c2. The equations can be written as 9x plus py equal to 1, 3x plus 4y equal to 2. So the value of a1 is 9, b1 is p, c1 is 1, a2 3, b2 4, c2 2. According to the question, the given condition is exactly one solution, and for this the condition is a1 upon a2 not equal to b1 upon b2. So from here we get 9 upon 3 not equal to p upon 4. 3 1s are 3 3s are. So we get p not equal to 12. P not equal to 12. So that shows that except for p is equal to 12, both the equations will represent exactly one solution. So the way we can write the answer is, answer can be written in three different ways. The first way is simply we write p not equal to 12, or we can also write it like this, that the value of p can be any real number except 12, or in symbolic form we can write it as p is equal to r minus 12. R represents set of real numbers. So except 12, the value of p can be any real number. Then let's take another example. Fine. This is a question for you. You can solve yourself. Question, do yourself. Find the value of k for which the pair of equations have unique solution, or represent intersecting lines. So the pair of equations are 2x minus 3y equal to 1, kx plus 5y equal to 7. Next question, let's take. The equations are 3x plus y equal to 1, 2k minus 1 x plus k minus 1 y equal to 2k plus 1. Answer to the previous question is k not equal to minus 10 upon 3. The condition given is no solution. So, first of all, let's write the values of, you have to find k. First of all, let's write the values of A1, A2, B1, B2 and C1, C2. A1, which is the coefficient of x here, 3. A2 is the coefficient of x in second equation, so 2k minus 1. B1 is coefficient of y in first equation, that is 1. B2 equal to k minus 1. C1 equal to 1. C2 equal to 2k plus 1. Now, condition is no solution. That is, A1 upon A2 equal to B1 upon B2 not equal to C1 upon C2. So from this we have 3 upon 2k minus 1 equal to 1 upon k minus 1 not equal to 1 upon 2k plus 1. Now we'll solve these two. So from here we have 3 upon 2k minus 1 equal to 1 upon k minus 1. Let's cross multiply. So we get 3 into k minus 1 equal to 1 into 2k minus 1. Three k minus 3 equal to 2k minus 1. 3k minus 2k equal to minus 1 plus 3. So from here we get k is equal to 2. But students, remember here, your answer is not completed here. After obtaining the value of k, we have to put the value of k in equation number 1 and check whether the condition is satisfied or not. So let's check. Put the value of k in 1. Three upon 2 into 2 minus 1. This will be A1 upon A2, which is equal to 3 upon 3, that is 1. B1 upon B2, 1 upon K minus 1. 1 upon 2 minus 1, which is again equal to 1. C1 upon C2 is 1 upon 2K plus 1. 1 upon 2 into 2 plus 1, which is equal to 1 upon 5. Hence we observe that A1 upon A2 is equal to B1 upon B2, not equal to C1 upon C2 for K is equal to 2. Hence, the answer is K is equal to 2. Right? Let's take some more examples based on this. It's a very important topic. So, another example. Kx plus 3y equal to k minus 2. (12x plus ky equal to k). Again, question is find k, and the given condition is no solution. Let's solve. A1 equal to k, B1 equal to 3, C1 equal to k minus 2, A2 equal to 12, B2 equal to k, C2 equal to k. Now the condition for no solution is A1 upon A2 equal to B1 upon B2, not equal to C1 upon C2. So we get k upon 12 equal to 3 upon k, not equal to k minus 2 upon k. Let's solve the first two. K upon 12 equal to 3 upon k. K into k, k square, 12 into 3, 36. So from here we get k equal to plus minus 6. Now it's not necessary that the condition will be true for both the values. So we'll check the condition for first for k is equal to 6, then for k is equal to minus 6, and then we'll reach to the conclusion, reach to the answer. For k is equal to 6, a1 upon a2 equal to k upon 12, which is equal to 6 upon 12, equal to 1 upon 2. b1 upon b2 equal to 3 upon k, which is equal to 3 upon 6, again 1 by 2. c1 upon c2 equal to k minus 2 upon k, equal to 6 minus 2 upon 6, 4 upon 6, which is equal to 2 upon 3. Hence, a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2 for k is equal to 6. Now let's verify for k is equal to minus 6. For k is equal to minus 6, a1 upon a2. Let's verify for k is equal to minus 6. For k equal to minus 6, a1 upon a2 equal to k upon 12, which is equal to minus 6 upon 12, which is equal to minus 1 upon 2. b1 upon b2, 3 upon minus 6, minus 1 upon 2, c1 upon c2, k minus 2 upon k, minus 6, minus 2 upon 6, upon minus 6, minus 8 upon minus 6, which is again equal to 4 upon 3. Hence, a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2. So we observe that the pair of equations represent no solution for both the values, that is k is equal to 6 plus 6 and k is equal to minus 6, or you can write the answer as k equal to plus minus 6. Next question. Next question is 3x plus 4y equal to 12. 3x plus 4y equal to 12. M plus n x plus 2 m minus n y equal to 5m minus 1. And the given condition is you have to find m and n for infinitely many solutions. Infinitely many solutions. This is 4 marks question. A very important one. A1 is equal to 3. B1 equal to 4. C1 equal to 12. A2 is m plus n. B2 is 2 into m minus n. C2 is 5m minus 1. Condition is A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. Hence, 3 upon m plus n equal to 4 upon 2 into m minus n equal to 12 upon 5m minus 1. 2 1s are 2 2s are. First let's compare the first two. Then we'll compare these two. So, when we compare the first two, 3 upon m plus n equal to 2 upon m minus n. So, we get 3 into m minus n equal to 2 into m plus n. That is 3m minus 3n equal to 2m plus 2n. This 2m transpose to this side, minus 3n transpose to other side, 3m minus 2m equal to 2n plus 3n. M equal to 5n. This gives you a relation between m and n. Now let's compare these two. 2 upon m minus n equal to 12 upon 5m minus 1. 2 into 5m minus 1 equal to 12 into m minus n. 2 into 5, 10m minus 2 equal to 12m minus 12n, or 12m transpose to this side, 10m minus 12m equal to minus 12n plus 2. 10m minus 12m minus 2m plus 12n equal to 2. Now we'll put the value of m here. Value of m is 5n. So minus 2 into 5n plus 12n equal to 2. Minus 10n plus 12n equal to 2. 2n equal to 2. Therefore, n equal to 1. N is 1 and we have m is equal to 5n. So, m will be equal to 5. So, the answer is m is equal to 5, n is equal to 1. Now for our satisfaction, we can check whether your answer is correct or not. Just check. M5, N1. Check. First equation is 3x plus 4y is equal to 12. In second equation, we'll put the value of m and n. M as 5. 5 plus 1. We get 6x plus 2 into 5 minus 1. 5 minus 1 is 4. 4 into 2, 8y. 5 5s are 25 minus 1 is 24. So here we observe a1 upon a2 equal to b1 upon b2 equal to c1 upon c2 equal to 1 upon 2. Hence, we have the answer as m is equal to 5, n is equal to 1 for the given pair of equations. Thank you. We'll continue this same topic in the next session.